Hello, I'm Roderich Gross. I'm a lecturer in the Department of Automatic Control and Systems Engineering here at the University of Sheffield. We are looking at swarm systems, and there are lots of swarm systems that you may be aware of in nature, like a flock of birds, a school of fish, or even the brain itself can be seen as a swarm system out of many millions of neurons, or an embryo is made of many cells. And we are interested in how these systems that are so massively distributed actually work, where there is no central entity that controls everything, but rather all the entities, all the individual parts interact with each other, and the complexity arises from these interactions. So this robot has a tiny little brain, it has two wheels to move around, it has a camera to see its environment, and it also has a number of other features. Sometimes we are using them, sometimes not, like microphones, a speaker, a accelerometer, and has also proximity sensors. So these are sensors to measure the distance to other objects like a wall or the distance to another robot. One of the demos is about the task of aggregation. It's the task where you have lots of maybe friends around in the city and you want to meet in one place. And these robots, we have restricted their abilities very much in this particular study because we were thinking, can you solve this task without any arithmetic computation, without any addition, without any subtraction, division and multiplication and so on? Can you do this without any memory? And why are we asking this? Well, we would like to know whether the swarms of the future, where the robots may be so tiny that you cannot see them anymore at the nanoscale, could also aggregate and solve these type of problems. And these robots may not be able to have the very powerful processors of your mobile phone. They may not have any memory and so on. So this is why we're looking at very basic robots. So in the second experiment, we are looking at the task of segregation, and it is a bit what you experience when you like muesli at the morning. You have some cereals that you eat, and you're shaking a pack of cereals, and what will happen? It will happen that the large particles, like the Brazilians, they go to the top, whereas the small particles, they go down. And in our swarms, we have now programmed the robots to behave like these muesli particles. So you have robots of 3 different colors, and each color represents a particle of a certain size. And as you will see that the robots interact, they're essentially doing 3 things. They're moving at random, which is like vibration, like shaking the pack of muesli. They are moving towards a light source, which is simulating a gravitational pull, and they are also getting repelled by each other, depending on the size of these particles. And all this together is enough to produce simple patterns like this. The transport control is interesting because basically they are pushing an object that we have here, and they are pushing it from the side, and if they don't see the target object that is over here, then they keep on pushing it because they assume it will be occluded, it will be behind the object, whereas if they see it, they don't push. So it's an extremely simple way of solving a task, and this is what makes this most exciting. Is the question, is less more? How little can be the complexity of these individual units to solve tasks that at the moment are fairly simple yet, but we are trying to push this frontier now towards more complex tasks where you see maybe division of labor, where you see maybe learning and so on. Where you have lots of resources that need to be moved from one location to another, and sometimes these may be quite heavy loads, and then you may want to have robots that assist this. It may be perhaps a human that determine where the resources shall be relocated to, but it can be teams of robots that take over this task. And it can also be in other scenarios, like in a disaster zone, to clean up the mess, or on another planet to deposit some resources. And so there are lots of possibilities for application with that technology.